Questions on any of those problems? Any questions on number 5? You'd like to see? That was the elimination method, right? Or we call it an addition method as well.
Yeah.
We solid, we're good, we're happy, completely content. As you're looking, I'll get notes out to you. So as you know, or maybe you don't know, come Thursday for y'all, obviously Friday if you're the other cohort, we will do a test on this stuff. Part of the test will be done on Schoology here in class. We have Chromebooks that we'll use. And part of it will be just a single, you can handwrite on the page. You're welcome. Did I get everybody a pack of notes? Did you see any problems you want me to work out, or you feel comfortable? Bless you. And you don't have to do the word problems, the 12, 13, though. You don't have to do those. We feel good? You sure? No fibbing? Well, I'm going to pick one to do then. I'm going to pick number 5. Number 5 is 3x plus 4y is equal to 11. And 5x minus 6y equals 31. Okay, so this is a great elimination problem, but you have to be real cautious on it. My x's and y's are both lined up, so I'm satisfied with that. I'm happy with that. But if I add the two equations together as they sit right now, nothing drops out. If I add them together, I get 8x minus 2y equals 42. Is that right? So that doesn't help because it still has x and y. So then we have to figure out. Usually my next step is there something I can multiply one of the equations by a single number to eliminate out? No, I can't multiply 3 by anything to make it 5. I can't multiply 4 by anything to make it 6. I can't do anything by 5 to make it 3 or by negative 6 to make it 4. So that's not there. So then my third step is I'm going to have to multiply both equations. But do I have alternating signs between my top and my bottom? Like, do the x's have a positive and negative, or do the y's have a positive and negative? And the answer is yes. The y's have a positive and negative. So I'm going to have to multiply both equations by something, and I truly feel the y's would be the one to get rid of. Okay, so now, what is the smallest number that both 4 and 6 go into evenly?
2.
Well, 2 goes into both of those, you're right. But what's the smallest number that both 4 and negative 6 go? And I think I heard 12? 12? 12, yes? All right, so 12. So I'm going to multiply everything here by 3 and everything here by 2. Okay? So if I multiply here, and then here, and then here, do you feel comfortable with that? I'm not done with the problem, but do you feel comfortable with how I did on that problem? Do the same thing with the second problem. Distribute 2 over the parentheses. Okay. So the x's and y's are lined up. If I add the equations together right now, the y's go away. Agree? So if I add these both together, just as I said, I'm going to get 19x those cancel, right? And then let's see, what's that? 5, and that's 95. Divide each side by 19. If you go, excuse me, 95 divided by 19, you wind up with x equals 5. So that's my first answer. That's an x value. So I'm going to pick one of the two green original problems. Doesn't matter which one you pick. And I'm going to plug 5 in for the x value. So maybe I pick this one. I plug in right there. So 3 times 5 is 15 plus 4y equals 11. Subtract 15. 4y equals negative 4. Divide by 4. So y equals negative 1. There's my answer. So that one worked out really nicely. Worked out really nicely. But you have to take care of both equations. So that's the tougher of the scenarios with elimination. Now, with that one done, is there any of the others you would like to take a look at? Okay. Hey, now, what would happen? What would happen if I had something like this? What would happen if these were my equations? I did this. Is that true or false? Indifferent? Those quizzes going okay? Quiz going okay? Quiz going okay? That's a no solution. Yeah. Yeah, this is a no solution because this is false. So that means we have no solution to this problem. Well, that means if they were graphed, that means they would be parallel to each other. Well, what if we had this? Is 0 equal to 0? Yeah. This week it is, I think. That's an infinite, yeah. Infinite solutions. Same line. If you graphed them, they'd lie right on top of each other. Okay? All right. Let me go to the notes now. So we're going to kind of review these. So we're going to review graphing, substitution, elimination. So which way seems better to solve this problem? Well, one, I'd say graphing's off the table because there's not even a graph available. Agree? Hopefully you're on your phones a little too much. So next thing, so there's no graph given. So graphing might be off the table. That's first thing. Second thing, can I solve for x or y easy? So can I take either of those equations, get x or y solved real easy? I don't think so. I mean, if I wanted to solve the top one for x, I'd have to subtract 4y from both sides and then divide everything by 3. So I have a big old fraction to plug into the other equation. That doesn't seem good to me. If I wanted to solve for y on the second equation, I'd have to subtract 4x and then divide everything by y. And then I'd have a big old fraction to plug in. And that doesn't seem good either. So with that known, neither of these are going to work. So then we have to look, say, okay, maybe I'll multiply this whole top one by 4, this whole bottom one by 3. So I get negative 12x plus 16y equals negative 20. Then I get 12x plus 15y equals negative, what is that, 42? Add them together, those cancel. So I get 31y equals negative 62. Hey, thank you very much.
No problem.
Let's see. Oh, that's for next period. Cool.
I have a question.
Yeah.
So if that -2 was a positive, what would you do?
I would have either the 4 or the 3 be one be negative, one be positive. And there's not a right answer on that. It's just if everything is like plus all the way through and plus all the way through, when you multiply both by two different numbers, one of them has to be a negative number. And when you do that, it's going to allow either the x's to be opposite value or the y's to be opposite value.
All right, and then
It's a great question.
it doesn't matter which one you do. Like you could do the y's or the x.
Yeah, you're right. You're right. It doesn't matter. So it's your choice where you want to start. So you might start one way, and then somebody else might start the other way. And you might have gotten x that you were able to solve for first because that's how you chose it. Someone might have gotten y first, but then your answers are the exact same. So it doesn't matter which. That's a great question. Thank you for bringing that up. Hey, so I've divided each side by 31. So y equals -2. So I get -2 as part of my answer. That's a y value. Yeah, so then I plug it in either here or here. Doesn't really matter which one. I might pick it into, put it in the top one. 4 times -2 is -8. Add 8, add 8. So -3x is equal to 3. Divide by -3. -1. Okay, so when you're given the option, how do you want to solve this? One, if I didn't give you an XY axis, I don't know if you want to draw one in. And again, we talked about it last time. Sometimes when you draw an XY axis, you don't draw it as perfect as the one I found graphically. Not because you're broken, it's just because you're human. I know when I draw an XY axis, I kind of do it real fast, and that's not real good to scale. So if you can't solve for a letter real easily, then the addition method or the elimination method are going to get you the answer either way. May I move on? Yay! Okay, solve the following. Which method seems good? Well, I don't have a graph. So I'm probably thinking graphing's not good. Even if I had a graph, I don't think it would graph really nicely. Because the bottom equation, if I use the cover method to graph it, I got some values that are tougher to graph. Okay, second step, is there a letter that's easy to solve for or already been solved for? Well, yeah, I got y equals this. If y is equal to that, I'm going to plug it in right there. So I get 5x minus 4, -3x plus 5 equals -3. X had, or y had been here, but I knew that y was equal to this, so I'm going to do that. Don't forget to distribute the -4. Combine your like terms, so I get 17x minus 20 equals -3. Add 20. Those cancel, so I get 17x is equal to positive 17. 17, that's a 17. So x equals 1. Sweet. So I'm going to take this 1, it's an x value. I'm going to plug it in either right here or right here. Which one would look simpler? Both get the same answer, but which one's more simple? Top, yep. I get y equals -3 times 1 plus 5. This is where x had been. Done. Done, done, done. So again, if you don't have a graph given, I'm not expecting you to be some art major and create some beautiful graph. Even if there is a graph coming, then you have to sometimes look at it and say, does it look like it graphs simple? If the answer is no, then don't graph. Last one. Now this one, I'm not giving you a choice. Why does graphing seem to be a good method? Well, the obvious reason is, well, dude, there's a graph there. Might as well use it, right? But when you look at it, this one works real well with the cover method. So that's a x value, so I cover that up. So -3 times what number gives me 3, and that'd be a -1, so 0, -1. That's a y value, cover that up. So -3 times what number? Oh, it's -1 as well. So you get that. Ooh, -17. Oh, it seemed like such a good idea to graph. Why am I steering away from graphing that bottom equation?
Because you don't want to count 17.
Yeah. As far as you all can see, this goes down to -10. So -17 is not even on my board. Oh, but graphing seems so good because you gave me a graph. But I can't graph. That -17 is off my grid. And I'm not expecting you to be that art major still and draw in that line and space out to 17 or -17. So that's not going to work because this is off the graph. So at that point, I wouldn't even mess with it on graphing. I think I might use substitution on this one. I think I might, damn, which one? I wouldn't even mess with graphing because that -17. Does that make sense to everybody what I'm saying? Okay, so graphing seems good. Well, I'm going to take that off and I'm going to use substitution. Substitution is great because y is equal to this. So if I plug that in right there, that was y, but now it's going to become a -5x minus 17. Distribute over the -3 here and here. Well, it's 3 times 17. I don't know, 3 times 7 is 21. Carry 2. 51 equals 3. Okay, let's see, that's 12x plus 51 equals 3. Subtract 51. 12x is equal to -48. Oh, sweet. 12 goes into that. So my x value is -4. You might be able to take this, and you can plug it either here or here. Which one looks better, top or bottom? Top or bottom looks better to plug it in. Bottom. Bottom already says, hey, y equals this. So let's use the bottom. Okay, I'm going to plug -4 in. There it is. That's my answer. So you have all kinds of different opportunities here. Some seem to work one way better than another way. You have to use a little bit of your thought process to decipher what's going to be better to use. Friends, I will tell you, if I have a graph shown and your graph is, one of your points is going to be way off the graph, steer away from graphing. It's okay. It's okay that I put a graph and you don't use it. Okay, now, if I tell you on the quiz or on a test or something like that, if I say, use graphing to solve this, guess what's going to fit on the graph? What I gave you, yeah. But I'm not going to say, graph this, and then all of a sudden you have to graph like 0, -200. That's silly. But if I say, hey, use whatever method you would like, and I provide you with a graph, well, take a look. Say, huh, well, that graph, no, it's not going to graph. Still not going to graph. He's trying to trick me. You know, I provided a nice graph. That was a pretty looking graph. I like it. But it's not going to work as well. Okay? Okay, so if you graph and the slopes are the same, what two things could happen? Well, what two things could happen? we could get infinite or no solution. Infinite means everything falls out and you get like 10 equals 10 or 0 equals 0 or 18 equals 18 or -3 equals -3. That's infinite. If you get a false statement, that wouldn't do. What would the result be in each case? So if you get true, then infinite. If you get false, then no solution. So you solve a system and your answer comes out to 10 equals 10. Well, that means you have infinite solutions. What about if you get -7 equals 10? Well, this is false. So this is no solution. So you just have to kind of be keen on what happens. Sometimes when you're working a problem, it's like, oh, this is a good problem. I'm feeling really good about myself. But everything dropped out. All my x's and y's are gone. All right. Let's see. Okay. So, my friends, give me 1 sec. Let me pause this. I need to just double check something. Here we go. All right. Now, this is the exact same thing, but there's an inequality there. Okay. So, if there's an inequality, this top one, that's set up as y equals mx plus b, so I get 0, -1. Slope, 1/2. Up 1, right 2. Because that doesn't have an equal sign underneath it, it's going to be a dotted line. Let me stop there. Is that okay? Second equation, when I graph it, I get 0, 3. Get a slope of -2/1. So from that dot, I'm going to go down 2, right 1. But this is going to be a solid dot, a solid line. Okay. So I'm not too concerned about where these two cross each other. I need to figure out a place that I can say, I want to pick a test point. Doesn't matter what test point you pick. I'd say just make it easier. So let me pick that as my test point. I'm just picking something that is far enough away from the stuff taking place. And I'm looking to plug in 10, 0 into both of my equations and seeing where it's true. So that's an x, that's a y. Does that make sense with the test point? You can pick any test point you want. The best test point to pick, if you can, is 0, 0. But if you can't pick 0, 0 because your graphs seem too close to it, then pick something, 0. Okay, so I picked 10, 0 because 1, I know it's easy to multiply by 10. So I'm going to plug that in. I'm going to go, this first equation, plug 0 in. It's greater than, what's half of 10? 5. Is 0 greater than 4? Not this week. So the first one gives me false. Okay, so I definitely am not going to shade in this region here. I could shade here, or here, or here, or we're not sure yet. So let's take that 10, 0, plug it in here. So I have 0 is greater than or equal to, what's -2 times 10? -20 plus 3. So 0 is greater than or equal to -17. That's true. So I get. So, okay, so now we have to decipher. This one gave me false. So it's false all below here. It's false all below the green. So I'm going to do this. I know above the green, it's going to give me true. So up here, this whole thing's going to give me true. But that's not the entire answer. If you shaded that whole thing in, you'd miss 1 point. Because that yellow region has one side of the purple line and the other side of the purple line. So this one down here, this one gave me a true. So I'm going to shade the above part. Now watch what I'm going to do. You art majors might get a kick out of this. I'm going to shade this side of the blue. Oops. Hang on. Undo, undo, blue. I'm going to shade on top. This is where I think you art majors might get a kick out of my board. I have 3 colors up there, yes? Which region is the region that changed color? The yellow, the green, or the blue? This region right here, is my solution. So you shade in your region. Let's see if we can make a little bit more sense. Okay, same idea. This is going to give me 0, 3, slope of -2 over 1, 0, 3 right here, slope down 2, right 1, solid line because there's an equal sign. So I get that. This one, 0, 1, slope equals 1 over 1, up 1, right 1. This is dotted because there's not an equal sign with it. Okay, I feel good about this. This test point right here, 0, 0, works. Oh, that's the best test point ever. Best test point ever. 0, 0 is best test point ever. Let's see if we can find 0, 0. If it's true, true, we shade down there. If it's true, false, it's not down there. Okay, so I'm going to get 0 is greater than or equal to -2 times 0 is 0. 0 plus 3 is 0 greater than or equal to 3. Zero greater than or equal to 3. It's greater, right?
Yeah.
Or is it not greater?
It's not.
0 is less than 3, right? So that's false. What color line was this one? Blue or green? Blue. So I'm going to shade the other side. I'm going to shade this side. I'm going to shade this side of the blue. And again, I'm shading the whole thing. That's great. Okay. So I know my answer is going to exist on that side. Now it's either up here or in here. It's one of the two. So let's take the 0, 0 and plug it into the other one. All right, so 0 is less than 0 plus 1 is 0 less than 1. Is that true or false? 0 less than 1 or is it greater than 1? Less than 1. So this is true. Okay, so if 0 is less than 1, means I'm going to shade underneath here. My friends, which region is our true answer? The green. So my solution to this exists in here. Okay, that's my solution. Again, when there's an inequality sign or 2 inequality signs, I'm not worried about where they intersect. The main thing is getting that test point. Okay, oh, that's supposed to be 2, I think. All right, this one should be cover method. That's an x, so 3 times 2, so 0, 2. 0, 2 is right here. It's a y value, 2 times, that's a 3. This is dotted because there's not an equal sign. Okay, good to go. Let's do the cover method on this one because it's set up that way. That's an x value, so -3 times what number? Oh, that gives me -2/3. So 0, -2/3, that's like here, kind of. This is a y value. That's -2. -2 is right here. Solid, because there's an equal sign. Now 0, 0 is pretty close, but I'm pretty sure 0, 0 is a really good test point. It's definitely underneath the blue, it's underneath the red. Take those, plug them in. 2 times 0, 3 times 0, 0 is greater than 6. That's false. That's false. It's false for the dotted line. It means I'm going to shade this side of the dotted line. Okay. This one, plug 0, 0 in. -0 plus 0 is less than or equal to 2. That's true. 0 is less than 2. So we know we want to be underneath the blue. So the test point's on the right side for that. My answer, green region. There's my answer. That's it. Okay, now I realize you might not have markers with you, and that's fine. You might not have markers, and that's fine. Very last question. We want to figure out using y equals mx plus b. This b value here is equal to 2. Then I'm going to go down 1, 2, right 1, 2, 3. So my slope of this is -2/3. So I'm going to go y, I'm going to put a blank right there, equals 2x minus 3, or 2/3. Okay, so that's my first equation. My second equation's set up to do the same thing with. So it looks like I have a y-intercept here of 0, -5. So my b value is -5. My slope, I'm going to go up 1, right 1, 2, 3, 4, 5. So my slope is 1/5. Then we have to figure out. What are my signs. I know this one will have an equal sign in it. Why can I say that one will have an equal sign? Because it's solid. And then from there, let's take a look. If I pick 0, 0, and plug it in, I'm going to plug it in here. 0 blank 2 times 0 minus 2/3. So 0, is 0 bigger than or smaller than -2/3? Should be bigger. That shaded that. Do the same thing with the bottom, plug 0, 0 in. This is going to be a blank still. We know we have an equal sign there. 1/5 times 0 minus 5. Is 0 is bigger or smaller than -5? 0 is bigger. Oh. Okay. We have the shaded region down here. So it's bigger. So if we go that will satisfy that region there to be shaded. This is a little tougher, but I think it's something that you are able to do. If you take your time, don't leave anything blank, do as much as you can. Okay, so with that known, stop sharing here, share here, share here. Courses, we're in the right courses. Let's see, Algebra 1. Let's see where we're at. We are in week 3, yes? So in week 3, okay. These 2 pages, And I'd say, let's do the odds on both of those. I'll change those both to odds. Let's do the odds on those two. Will be next time we have class. This one right here will be due on Monday. That's our remote day, yes? Okay, so these two will be due next time. We have a quiz next time. Part of it we'll use on our own computers here in class. And then part of it will be on pencil paper, on a piece of paper. Questions for me, friends?
Quiz is on Thursday.
Yeah, quiz is next time we have class.